Sometimes when you go to solve a trigonometric equation, you'll notice that you have different trigonometric functions mixed up together. So in this question, we have cosine and we have sine. So simply solving by factoring or solving for one trigonometric function isn't possible. So we're going to need to use some of our past information. And whenever you see a sine squared, it's a pretty good indication, or a cosine squared, that you're going to be using the Pythagorean identity: sine squared plus cosine squared is equal to 1. In this case, we want to turn this sine squared into something about cosine. So if I subtract cosine squared from both sides, recall that that gives me sine squared is equal to 1 minus cosine squared. So we can take this trigonometric function and substitute it in right here. What will that give us? That will give us 3 cosine theta plus 3 is equal to 2, and in its place we will substitute what we got over here: 1 minus cosine squared theta. Now that we've done this bit of substitution, we can see that we are down to just the word cosine, or just the trig function cosine. So now it's doing a little bit of algebra and getting everything on one side. Remember, when you're going to be factoring, it's always easiest to have the squared object as a positive leading coefficient. So let's do a little bit of work here, and let's turn all of these cosines into the letter C. That will help us with the solving a little bit and make that part a little bit more algebraic looking. So we're going to have 3c plus 3 is equal to 2 minus 2c squared. We want to get everything on one side and factor. So I'm going to bring the negative 2c squared to the left, and then I'm going to subtract 2 from both sides to get a 1 on the left, and this will be equal to 0. Then we need to use all of our factoring rules, and whatever method for factoring when a is not equal to 1 you use is going to work. And now that we have two factors, we'll set each factor equal to 0, just like when we are solving any equation. So we get that c is equal to -1/2 and c is equal to -1. But remember, c stood for something here. C stands for cosine. So we need to keep solving because we need to find all the angles theta where cosine is equal to -1/2 and where cosine is equal to 1. So we head to our unit circle. We want the x coordinate, cosine sine, we want the x coordinate to be -1/2. So that's going to happen at 2 pi over 3, and that is going to happen at 4 pi over 3. So 2 pi over 3 and 4 pi over 3 will be the answer for the first thing that we are solving. Then we want cosine to be a 1. So if we go back to our unit circle, we want the x to be a 1. Well, that only happens here at 0 radians. So our third answer will be 0 radians, and we get 3 answers to this equation. Let's move on by trying this function. Notice again, we have cosine with a sine squared. You have to have either all sines or all cosines in order to do this question. It would be tempting to try to change this cosine because it's a 1 minus cosine. But remember, Pythagorean identity is 1 minus cosine squared. So let's go back and look at our Pythagorean identity. Sine squared plus cosine squared is equal to 1. If we subtract cosine squared from both sides, we get that sine squared is equal to 1 minus cosine squared. We can then take this 1 minus cosine squared and substitute it in for this sine squared, and that will give us a completely different equation. It will give us 3 times 1 minus cosine is equal to 1 minus cosine squared. Now, at this point, I suggest, now that we have all the same trig function, we'll go ahead and change the word cosine into c's, and then we'll solve this like an algebra problem where we have to get c by itself. So it looks like I need to distribute the 3. And remember, we're going to have to factor this, and that's always easier if the coefficient on the c squared is easier. So I'm going to add c squared from both sides, and I'm going to subtract 1 from both sides. That 1 is a constant, so it will be subtracted from the constant 3. And it looks like we're going to get then 2 minus 3c plus c squared is equal to 0. Rearranging this into x squared plus bx plus c form, we get c squared minus 3c plus 2 is equal to 0. Now we can go ahead and factor this. So cosine minus 2 and cosine minus 1, because negative 2 times negative 1 is equal to positive 2, and it adds to negative 3. So we get cosine is equal to 2, or cosine is equal to 1, or c equals 2 and c equals 1. But remember, c stands for cosine. So we want to know, when is the cosine equal to 2, and when is the cosine equal to 1? Well, if we remember our function sine and cosine, what's the biggest that a cosine will ever get? Positive 1. What's the smallest it will ever get? Negative 1. So it is impossible for cosine of theta to ever equal 2. So that part will not give us an answer. The only thing that we'll get an answer is from cosine theta equals 1. So we'll head to our unit circle. Where is cosine equal to 1? Well, it's equal to 1 when theta is 0 radians. So our final answer here will be just 0 radians.